Let's talk about LIDAR for a bit, because a lot of times people will set up their LIDAR in the incorrect spot, and then they're trying to match up their house to incorrect LIDAR. Now, even when your LIDAR is set correctly, it's important to know when your house is correctly matched to that LIDAR. So we talked a little bit about it in building a basic roof structure, but here I want to go a little bit more in depth. So I'm going to turn on LIDAR here, and a lot of times when you turn on LIDAR, this is what you're going to see. Your house is over here, but you can see the LIDAR is saying it's over here. What I like to do is I like to look at it from top down in a 2D view. Basically, I have to move it west and north in this case. If you have a lot of ground to cover, click and drag this bar. It's going to cover a lot more ground faster. But when you start getting it closer and you need to move it in smaller increments, click in this box here and use the mouse scroll wheel to move the LIDAR shorter distances. My goal here is to try and get the LIDAR to be matched up to the gutters as well as the ridge as best as I can. But the gutters are going to be the easiest point of reference right now. So I don't want too many dots hovering over on either side. I want it to look pretty equal. So it looks like it's pretty closely matched up as far as left and right goes. You can see also that the LIDAR is too far south, so we have to move it a bit north. So that's going to be the Y offset here, and I'm going to drag that up until the dots are sort of matching up with the rake there. You just have to get it in the rough general area because you can adjust it as you go. You just want to make sure it's close enough to get started. Now let's talk about how high you need to make your LIDAR. Now, a good basic point of reference before you start building a home is to put your Z offset for your LIDAR so that you're seeing the dots poke about halfway through the street. Now, that won't be the case for every home, but that is your point of reference. If the ground is perfectly flat, you should have your LIDAR dots poking halfway through the street in front of the home. However, if the house is on a hill, you have to make adjustments based on that. But what you're basing your adjustments on is if the ground was flat, the dots being in halfway through the street in the front of the house. So, on this particular home, the driveway is kind of sunken in and going downward into the home. So I'm going to make adjustments based on that and put my dots sticking about halfway through the driveway. Where normally you would have the driveway going a little bit up or flat, this one sinks downward. So I'm just going to raise the Z offset until those dots are sticking about halfway through that driveway area. Okay, so now our LIDAR is set, at least good enough to start matching our house to it. So if I click on my house once, and I use this arrow here to click and drag and raise my height, my goal here is just to match up the gutters first. I'm just going until my gutters are poking about halfway through the dots. Now you can see my dots on the left side are a little bit more buried than my dots on the right side. So that means I need to move my LIDAR a little bit more to the left. This looks a lot better because it looks like I have equal dots showing on both sides, as well as my ridge is going to match up a lot better this way. It also looks a little too far north, so I'm just going to scoot it down to the south just slightly. So the gutters are looking pretty close, but I'm going to still have to raise it just a tiny bit. There we go, that looks a lot better. We want this line here to be cutting halfway through the dots in that area, and we want that happening on both sides. So here is a big red flag that a lot of people miss. A lot of people would look at what we have now and call it good and say it's matched to LIDAR and move on. And that would be wrong. My house is at the wrong pitch, and you can tell I have the gutters at the right height, but the ridge is not matched up. You can tell because the dots down by the gutter have about half the dot showing. It's cutting about halfway through. However, the dots up by the ridge are almost completely buried. Some of these dots I can't even see at all. That's not what we want. We want half of the dot showing here and half of the dot showing here. To do that, I'm going to double click the home. I select one of the roof faces, and in this case I'm going to check this box that says apply to all roof faces. Click into this box where it says pitch, and I'm going to scroll downward to lower the pitch until we can see the dots equally across. Now 18 degrees looks a little bit too low because you can see that some of the dots here are a little bit more visible than the ones by the gutter. I can see almost an entire dot right here up by the ridge where it's half down by the gutter. So I scroll it up 1 to 19 degrees, and that's good. Now, 19 degrees is kind of a weird pitch, and I'll tell you why that's weird. It's because there are kind of some standard roof pitches, and it goes kind of in a pattern like this: 0, 2, and 5. Now, when you first draw a shape in Aurora Solar, it's going to default your pitch at 20 degrees. So let's look at it this way. The standard roof pitches are 20, 22, and 25 degrees, 30, 32, and 35 degrees, 40, 42, and 45 degrees. You get the idea. Now, mostly it's going to be within that range of 20 to 45, but you will find some outside of that range. Those are just kind of the standard guidelines of roof pitches. So normally you're going to want to make it one of those standard ones. However, if your LIDAR is really clean like mine is here, just match the roof to LIDAR even if it's a weird one that's not one of those standard ones. If my LIDAR was a bit more messy and I was matching it up and I was at 19, I would say, since my LIDAR is so messy, it's probably a little bit off. I'm just going to make it the standard 20 degrees. However, since my LIDAR is very clean, I'm going to trust it and I'm going to go with 19.